Good day, weather technology students. In this video, we're going to demonstrate how to plot satellite imagery using MetPy and the declarative syntax we've used for the majority of this semester. So go ahead and open up a terminal window and navigate to your Met130 working directory. And we're going to go ahead and copy over a new notebook file that's going to help us demonstrate this from part 1 of the handout on plotting satellite imagery. And so we need to go back a directory to valpo_courses, WeatherTech, notebooks, and then capital S satellite_imagery.ipynb. Go ahead and give that a copy over, and we should then see a new file appear here. Go ahead and get that open once you get it copied over. Don't forget to change that kernel, and we'll be ready to go. Again, satellite data is quite amazing to plot. It's such a useful tool for us as meteorologists. If we were working locally, we do keep, a couple of days worth of satellite imagery. I mean, literally like 2 or 3 days worth of satellite imagery, because with our current series of GOES satellites, the data is robust. There's just a lot of it, both in time and space. And with our limited ability to store things, we only keep it for 2 or 3 days. But since we're working a bit more remotely this semester, we're going to then go ahead and access data from UCAR, as we've been doing a lot this semester, because they provide a lot of great current data for us. So again, here in this import here, we're going to bring in a lot of the classic things. So we've got our daytime, our MPCalc, we've got our declarative plotting, our units, NumPy, and then we're bringing in this piece from Siphon called the TDS or Threads Data Service Catalog. That's going to allow us to get easy access to our satellite data. And then Xarray for making sure we can read it in an appropriate format. So go ahead and import all of the packages that we need. Again, what I've done here to help us out a little bit is I've created a helper function. And so the way that the data files are organized is they come in to our thread server and have a really kind of long date going on. And so if we go ahead and look at this particular channel here, we can see what this might look like. So I'm going to copy and paste this, although this may not work because this is data that is well past. So we're going to go ahead and paste that, and then we're just going to actually go back to just the original threads. And then we're going to navigate, so from threads.ucar.edu, we're going to go to the satellite data. And then we're going to go to GOES East products. We don't want the GRB, the rebroadcast. We want the GOES East or GOES West products. And then we want cloud and moisture imagery. And then we're going to primarily focus on the CONUS, although one could do full disk, mesoscale, and Puerto Rico if you wanted to. Then we see we have our 16 different channels. Let's start out with channel 2, which is our visible channel. And we see they keep, about 2 weeks worth of data. And so we can click on any one of these. And here are then the files that we're going to read in. You might be like, oh my God, look at these files. They are obnoxiously long. And, we may not always want to plot just the most recent. The most recent would actually be relatively easy and simple to get at. But, if we wanted to plot something from within the last 2 weeks, we would need a way to then search through all of these files from a particular day to find the file that is closest in time. Unfortunately, these dates in here, our start, end, and center dates, which are really times, are in something called Julian days. So days between 1 and 365 or 366 in a leap year. And so what I've done with this function is I've gone about making a way that it can run through this list to find the one that is closest. And so that's really all this helper function does, is help us find the right file that's closest to the time that we desire. So that's why we need it. And so then if we want to go ahead and plot something up, we can plot something up. This is from March 28th, which should still be active when I am going to run this. May not be active when you are running it, since again, they only keep about 2 weeks worth of satellite data. For the region, which is our CONUS, instead of mesoscale 1 or mesoscale 2 or Puerto Rico, we're going to do CONUS, specify channel 2, and we want GOES East data. all of these pieces, the date, the region, the channel, and the satellite, all go into creating this string here that we're creating in this variable called data URL. And so we're basically recreating this entire string that gets generated if we go to one of these images here and go to our OpenDAP access point. Here is the entire string that we would need to do for this one, but we don't want to have to go through and find it every single time. And so we're creating it because most of it stays the same, and we're only modifying it based on certain things. Based on the region, which is that's going to be CONUS, our channel, which is going to be a 2-digit channel number, and then the year, month, day from our date. And so then we are going to go and use the threads catalog with that data URL to basically get all of the various values that are available within the catalog for a particular day for a particular channel. So really what we're doing is we're not even getting down to this level here. We're basically getting to this page here and wanting to parse this page to find whatever time is closest to the time we desire to plot. And so then, from our helper function here, get satellite file URL, we're going to feed it all the different data sets that are available within our catalog, which is that's what's coming from cat.datasets. And then we're also feeding it the date time that we want, right? And that's what our input here is to our function. A list of data sets from our threads catalog and the date that we desire. And then what it's going to feed back to us is the value or the index value of the one that is closest to what we want, such that that is what then is we are getting from our data set, right? So this is basically going to give us back a value, the index value for where the data set that we want is, so that we pull in the right data set and then we access it using Xarray remotely. And so since we're doing channel 2, we're also going to apply a correction. So it turns out that our satellite sensors can sense beautifully the radiation that it receives in a very linear format. Unfortunately, our eyes do not actually perceive light in a linear fashion. There's a bit of a non-linearity there. And by taking the square root of the values, that will make it a brighter image, a more dynamic image for us to see, and that's why we apply this correction. And so we're applying it just to channel 2. Really, we'd want to do it to any channel that is a part of our reflected imagery, which would be channels 1 through 6. And then we're pulling out the valid time here with this line of code here, which is similar to what we do for our gridded data. So let's go ahead and run it and pull in our data. It takes just a minute to do this. Our channel 2 is our biggest data set here. And we see that it went ahead and we got it in. And then to plot it up, it's a very, very simple plot. We're going to use our image plot from our declarative syntax. We're feeding it data from our DS data set. We are wanting to plot the field sectorized CMI. This is sectorized cloud and moisture imagery, which is the name of our reflected values that we then updated with the square root of them. And we're applying the color map of grays in reverse order. And then giving it a title with some formatting in there, plotting just our image on there, and then plotting it on our panel. So let's go ahead and see what we got. And here we have our nice visible imagery from March the 28th. This was shortly after a cold front had moved through, but I believe we even had a little bit of maybe lake effect snow going on this day. But we can see the land clearly in the clear areas. We can see high level clouds, some lower level clouds up here, all the way down to the water in the Gulf of Mexico. And so our visible satellite imagery is really, really nice. And again, if we were to go ahead and get our data but not apply any sort of correction, we could comment this out and we could see what that looked like. And it's going to be quite a bit darker of an image. There we've got our data read in, and now we're plotting it up. And so we see it's a much darker image, a little harder to read. And this is what the satellite actually sees in a raw sense but it has a much more dynamic range because it senses radiation linearly. So that's why we want to go ahead and keep that correction in there. And so that's it for plotting up satellite imagery. It's pretty easy. And so we're not relegated to just the visible satellite imagery, which we're replotting here again. But we could say plots water vapor. We would just need to do a different channel, or infrared. So we're going to go ahead and do channel 13, which is a common infrared channel to plot. We're going to bring that in, read that in. Again, using our helper function, and then plotting it up using our grays. Except in this case, this does not look like what I want it to look like. And so it turns out we don't need the reverse order on our grays here for our infrared imagery. And so we just take away that _R. And now we get here, where we see our clouds. Here, cloud top temperatures, definitely lower clouds where it's warmer here. Higher clouds where it's brighter. Definitely some stratus looking clouds when we looked at our stuff from before. For the visible satellite imagery. So again, the combination of satellite images here can really help us out. We can also look at our water vapor imagery. Look at channel 9. And there's our water vapor imagery. Again, now we're seeing that, there's a particularly dry area, probably a strong jet stream associated with this area right here. Wouldn't be too surprising. We could add overlays to this map if we wanted to by reading in a different data set, say the GFS, to plot some contours, and we'll go ahead and do that in a different video. But here's the basics for plotting up satellite maps. Hope you enjoyed it. Thanks for watching.